Hello everyone, welcome to my channel Data Gyani. Through this channel, my goal is to provide content that is highly relevant, well researched and advanced, yet easy to understand and apply in your professional journey. Thank you for your feedback on my previous video. I am constantly improving and working on bringing new and relevant content. If you find my content helpful, please like, subscribe and share with your friends and colleagues. Let's quickly talk about what are we learning today. We are going to see how using hyperparameters and regressors in your model can boost your model performance drastically. We are also going to touch upon how we can use regressors like hyperparameters automatically in our models. I am going to show how you can build your base forecasting model in less than 15 minutes. Lastly, I am going to use recursive and sliding window methods for forecasting and showcase advantages and shortcomings. In case you don't know what are those, you can refer to my previous video, the link for which will be in description. Before diving into the code, let me talk about a few areas where we can use today's learning. Forecasting is base for many decision making in professional and personal life. Let me share an example for each. Let's say you are an electronic retailer. By your previous experience or knowledge, you know that the demand of ACs is going to be more in summers. Imagine if you have a system that can suggest, based on historical trend, that you should stock 100 units. You will be happy to stock, isn't it? Let's now take an example of personal case. You know that it rains in July, August and September. And based on that, you carry umbrella every day for 3 months. Imagine you have an engine that suggests rainfall. You will now need to carry umbrella only when the chances of rain is high instead of every day for 3 months. Now here are a few areas where forecasting is widely used. Feel free to pause the video and read through. I will also post this in the description. Let's now dive into the code. As stock data is easily available and reliable, I will continue to use this stock information extracted from Y Finance. I'm using Apple stock prices for our forecasting analysis today, and I'm extracting data from 2010 onwards from Yahoo Finance API. Now I'm displaying first 5 rows to ensure that the data has been extracted properly. I'm doing the similar thing for last 5 rows as well. I'm using closing stock values, that is close, for forecasting here. Now let's say you want to forecast multiple variables. Then you simply need to add name of that variable in this list separated by comma. Slight disclaimer though, that these variables will be forecasted independently. I'm also declaring the forecast period and the validation period. Now, as I mentioned in my previous video as well, that profit needs input in DS and Y format, and that's what I'm doing here. Now, in case you observe outliers in data during exploratory analysis, you can use this function to remove your outliers. Here, I'm creating a function to split stock data into train and validation set. Now here, I am creating a function to check for multicollinearity using variance inflation factor. Now we are doing that as we are planning to add regressors in the future use cases. Scrolling further, here I have created a function to plot forecast as an extension of historical data. Here I am saving the output by creating a separate folder for each of them. Now, as I mentioned during the start of my video, that I want to showcase how hyperparameters help in improving forecast. So the model that I'm creating here will be without any hyperparameter or regressor. In train profit function, I am initializing the model and generating prediction in recursive manner. Here you need to understand that I'm training the model once, but using the same train model to generate a one-step forecast, then feeding it back into the model here and generating forecast again. I'm following the same thing in the validation as well. Later, I'm computing the evaluation metrics. The next function that I'm creating is find optimal params. This will be more active in later models. As you see, I am passing an empty grid. Finally, I am creating a main function where I'm calling all the functions above in a sequential manner. Now starting with split data, then training the model, generating prediction for validation and comparing it with actual and computing metrics. Next is the crucial step, as now I will be generating the future forecast beyond the validation period. Here I am combining the train and validation data and refitting the model. I highly recommend this step as it allows model to learn from the most recent data and trends and hence end up improving the future forecast. You will observe that I am getting a fairly good RMSE and accuracy. The objective becomes very important here, as my objective here was to minimize RMSE, and it may differ in your case. I am now printing values to see how close is the forecast against the actual value. Now below I am printing to see how my future horizon looks like. Now the next step is where I am optimizing my forecast using hyperparameters. Now if you know about profit, then you would know that monthly and quarterly seasonality is not part of its hyperparameter list. But when you are working on daily data, it has high chances of monthly and quarterly seasonality. Hence, I am adding it like this. Rest, make prediction, and validate model function remains the same. What changes is your find optimal params function, where the grid now has various options. With this, model will automatically keep or remove the parameters. You can also observe add monthly and quarterly here along with profit hyperparameters. It will now work in the same way that its internal parameter works, and it will work towards minimizing the RMSE. Rest of the code remains the same, and now you will observe that the metrics has improved. You have better RMSE and accuracy now. If you look at best parameters that model has selected, you will find the presence of monthly and quarterly seasonality. Now you can work on investigating whether it's actually present or not. And this kind of information is highly liked and generally very useful for business or clients. Let's dive into the next type, where I'm using both hyperparameters and regressor to improve my forecast. Now the word regressor is something that I will be interchangeably use with features. In case of first functions, I am creating features like rolling mean, standard deviation, and expanding a standard deviation. You can create more regressors like this, like lag, median, etc., whichever helps your model. However, you need to be cautious on the collinearity aspect, that your regressors or the features that you are choosing are not collinear within themselves. Next up, I am creating a function for differencing as many times model fail to capture complex patterns. And this feature helps in easing that for models. Now, we want to automate the process of selecting the regressor. Hence, I have used the same technique that I used above and passing the regressors as true and false in the param grid. If regressor improves the forecast, then it keeps, else it does not use it. Now, to make prediction and validation, I have passed the regressor in the loop as we want future value of these regressors as well. So the code now generates a forecast, feeds it back in the model, and then calculate the features and then use it to generate forecast again. Rest of the code remains mostly the same. You will observe that the forecast accuracy has drastically improved. At the same time, RMSE is also reduced to 4.7. Now you can look at the parameters and see what has been used and removed. You will observe the output of VIF function, and it suggests a collinearity between rolling mean and expanding standard deviation. Now you can run the model at your end without one of these factors and check the output as well. Now, to further showcase why choosing the right method is important, let me show you a comparison between the recursive model that I earlier built with the sliding window method. Here, I am keeping everything similar to what I had done in the case of recursive method. I am building this model with no hyperparameter or additional regressors. If you observe closely, then my parameter grid for this particular sliding window method model is empty. The thing that you will have to do differently in case of sliding window method is that you will have to train the model again on window size, generate the forecast, then slide the window, train the model again and generate the forecast again. Just by doing this, you will observe that the model is generating better forecasts than your best recursive model. It has higher accuracy and lower RMSE than the best recursive model that we built. The best window size that has been chosen by the model was 30 and the parameter dictionary is empty. So it has built the model based on its base parameters. This proves my point that no matter how well you optimize your models, if you do not choose the right method, you might not reach the optimal forecast. Let me again quickly highlight the differences between recursive and sliding window technique. I have covered some of them with examples during the video. You can pause the video and read it here as well. With that, thank you for staying till the end of this video. Let's look at what to expect next. I am planning to bring a video on constraint forecasting technique, which are prevalent in inventory planning, spares planning, etc. The technique that you have seen so far in my two videos is a part of unconstrained forecasting technique. I am also planning to create a new stream for GenAI related video only. And lastly, I am going to showcase an app that uses forecasting and optimization technique to optimize equity portfolio returns. But there will be a twist in this. So it's going to be huge, guys. So stay tuned and don't forget to like, subscribe, and share.